In this video, I'm going to show you the basics of some logarithms and how logarithmic equations are related to exponential equations. Okay, everything in math has an opposite operation, and exponential and logarithmic are opposite operations to each other. All right, so we're going to start with, what does a logarithm look like? Okay. So you can have something that looks like this. Log base A of x is equal to y. A couple things you need to know. Your base of A has to be greater than 0, okay? And your x value has to be greater than 0 as well, all right? And this is how you read it, log base A of x equals y. Now, what does that look like as an exponential equation? Well, your base is your base. So you have a base A. And this is where it becomes, well, one of these is your exponent and one of these is the answer. And it's weird, but the exponent's actually over here. So it's going to be A to the y is equal to x. All right. And so this exponential equation is exactly the same thing as this logarithmic equation. So that's kind of how those two are related. And again, over here, you'd still have A is greater than 0, and x is also greater than 0 in that case. All right, y can be anything because y is the actual exponent. Okay. So we're going to spend a little bit of time here in the first part of the video just changing between logarithmic and exponential to logarithmic. And if we need to, we might solve a little bit. So the very first one is, I think, actually what we just did. So you've got a base A raised to the power of x is equal to y. Okay, so its base is right here. This is your power. It's right there. And what I refer to as the answer, all right, is right there. So make sure you get them in the right order. Now, problem number 2 here, we're already running into some problems because there's no base. All right, mathematicians get lazy about things, and there are certain things that we just assume. So let's say, for an example, you have x is equal to root 5. There's a whole bunch of assumptions we have in here. We assume there is a 1 in front of the x. We don't write it. We assume that this x has a power of 1. We don't write it. We assume that this square root has an index of 2. We don't write that either. So all of these things that we assume, there is something that we get to assume with logarithms as well. When you have a log with no base, it is assumed that the base is 10. All right, that is the assumption. So what this turns into is 10 to the third is equal to 1,000, which, by the way, is a true statement. All right, if you take 10 to the third power, you get 1,000. All right. Something new. All right, ln. ln is called the natural log. All right. And it has a different base. Its base is going to sound weird, but its base is the number e. Yes, e is a number in the same way that pi is a number, in the same way that I is a number. It's just a number in math, all right? So this would translate into e to the y is equal to x. So the process doesn't change. It's just paying attention to what that base is when you're dealing with the natural log, or ln, as opposed to the logarithm of log, all right? That's the base 10. All right, so let's go with ln here. So natural log is a base e. So e to the second is equal to x. Okay, and you can find the E button on your calculator. It's actually right around where the log button is, okay, or natural log button. Okay, so problem number 5 through 8 says to write each logarithmic equation as an exponential and then solve if you can. So let's translate it first into a exponential equation. So we have a base of 3, power of x is equal to 9. we can solve this very quickly. X is equal to 2. All right, so both of these would be part of our answer because that first part was writing it as an exponential, and then the second part was actually solving it. Okay. Number 6 here, we have a base of x, power of 2 is equal to an answer of 4. So what squared is equal to 4? Well, x in this case can only equal positive 2. Let's say we took the square root here. If you did this and you said x is equal to plus or minus 2, because we're used to doing that with the when we put the square root in, remember though your base has to be greater than 0. So in this case, it's only positive 2. All right, so be careful with that. All right, problem number 10, we don't have a base written. So log base 10 of x is equal to 2. So 10 squared is equal to x, which makes x equal to 100. And again, both of those are part of your answer. And so let's see what number 8 looks like. We have a natural log here. So this is going to be an e. So e to the 5th is equal to x. Now, I can't do e to the 5th in my head. So I'm going to go ahead and swipe up, and I'm going to grab... actually, I'm going to close this for a second. I'm going to grab my other calculator. So calculate 84. And I'm going to go ahead and open back up to what I had Notability on and just do a quick split screen. Okay. So let's clear out what I have this mess in calculate 84. So E is located right here, right down here. So you've got your onbitten, ln, and log. And right here, it's in blue letters. It says e to the x. So I'm going to hit second and then ln. So second ln gives me the e. And it's already popped up into the exponential, into the power location. So e to the 5th. And I'm going to set that equal to. Clearly, I don't want all of those values. So let's say it's rounded off to 2 decimal places. So 148.41 is equal to x, approximately. So actually, let me write that as an approximation. Okay. If you're wondering what e itself is, so if you do e, whoops, hold on a second. Let's try this again, clear that out. If you do e to the 1st, okay, e itself is equal to 2.7182, and it keeps going. It's an irrational number like pi, which means we can't write it as a fraction. All right, but that's what e is equal to. It's just, again, it's just a number. Okay. Let's see what else we had here. All right, so we've gotten through 1 through 8. I'm going to go ahead and close the video here. In the answer key, when I post it, I will have the answers for 9 through 16. Those are all just converting from exponential to logarithmic. So it's basically doing the reverse of what we've been doing, but that'll be in the key. If you have any questions or concerns, send me a message or send me an email. All right, I hope this has helped explain a little bit about